So let us start, Kana. So are you ready with and if you're not having TND note, no problem. But you should possess a pen, calculator, and a notebook. Mm. Is my screen visible, Kana?
Yes, ma'am, visible, ma'am.
Start. So first experiment number 1. So what is our experiment number 1, Kana? Are you having your list of experiments with you? Anyone? See, a kind request to you. Any one of you kindly reply me yes or no so that it will be easy for me to proceed.
Yes, ma'am, we are having the list, ma'am.
Okay, okay. Let me share my entire screen so that it will be easy for me to skip. Okay. Now, Word document is
Yes, ma'am, visible, ma'am.
okay, okay. So this is our first experiment, and this is the first experiment in your first cycle also. Okay. So computation of line parameters for single and double circuit lines. Okay. So we are going to have calculation of your line parameters. Okay, in your transmission line. So we know the basic concept. Transmission line parameters are your resistance, inductance, and capacitance. Is it not? There is a rho L by E calculate using your rho. But we have to give importance to your inductance and capacitance if we consider for your transmission lines. Okay, and we have discussed the basics. What is a solid conductor? What is a bundle conductor? You know what is a single circuit and double circuits, everything. Okay, so in our experiment we are going to focus on a three-phase line alone. Okay, three-phase single circuit solid conductor, three-phase single circuit bundled conductor, and double circuit bundle. Totally four categories in today's experiment. Okay, so we know that we have line parameters are L and C per phase per kilometer for a single phase double circuit and three phase double circuit for different conductors. Okay, this is the explain. Uh, Now we move to the basic concepts. Just I recollect the concepts and figures and formulas which we are going to use in this calculation. Okay, is this PPT visible, Kana?
Yes, ma'am.
Okay, okay, thank you. So we know that your inductor, resistance, and capacitance, all those things come under electrical design of a transmission line. Okay, so if we discuss your mechanical design, we'll be having tower. Technically speaking, if I for transmitting a power, I should design these parameters. Okay, resistance, inductance, capacitance, and conductance. Okay, so in this, resistance is easily calculated using by rho L by A. and your conductance normally we assume it to be a 0. Okay, G we will always assume to be a 0. So now we are going to give importance to conductance and capacity. Okay, let me read classification. Have you all remember this, Kana? This is the thing you have studied in your TND, and all the 16 cases you have solved a problem. Is it so?
Yes,
So
ma'am.
let me thank you. Let me once again go through it. So normally your overhead transmission line. So this type of line is your overhead line. So it is classified into single phase and three phase. We know, and double circuit. Okay. So in single circuit, you will have solid conductor as well as your bundled conductor. Solid conductor means one conductor per phase. Bundled conductor, you will be having a classification of two conductor, three conductor bundle. Okay. Same thing for single phase, double circuit, solid, and single phase, double circuit, bundled. In bundled, two conductor, three conductor, and four conductor. Okay. So now we are three phase also. Three phase single circuit solid and three phase single circuit bundled, and in double circuits three phase double circuit solid and three phase double circuit bundled. Okay. So let me give you 5 seconds or 1 minute. You just have a classification notebook. It will be at least you draw the second part, because here we are going to concentrate in this experiment your three phase alone. Three phase single we are going to do, and three phase filled with two. This is our case 2, and three phase double circuit solid. This is our case 3, and three phase double circuit bundled. This is our case 4. At least you write these 4 cases alone in your notebook. Shall I move to the next one? Okay. So the values figure, just to say you how a three phase single circuit it will be. Okay. So three phase single circuit, you will have three conductors. This is a solid case. Okay. Next one. Things will be familiar to you because you have solved the problems already. And this is three phase double circuit line with solid conductor. So A, B, C, and A dash, B dash, C dash. Okay. This is not a transposed line. Okay. If it is transport, what will be the changes in this diagram, Kana? Anyone? This is a non-transposed three-phase double circuit transmission line. If it is a transposed line, what is the changes you have to do here? Anyone? Any guess? See, you should no need for yes, Kana.
மேம் ஏபிசி அந்த நெக்ஸ்ட் சைடு வந்து ரிவர்ஸ்ல போகும் மேம் சிபி.
Okay, very good, very good. So on the either on left side or on right side you can change, no problem. So normally this A dash, B dash, C dash we will put it in the reverse order. Okay, just like in this figure. Okay, so this is double circuit bundled conductor. See, each phase is having two conductors. The problem which we are going to see in our experiment is also exactly the same arrangement. A transposed line we are going to see. A, B, C, And if you see for transposed line A dash, B dash, C dash, it is in the reverse order. What is the need for transposing, Kanna? Why we are going for transposing? Okay, in order to improve the inductance, we are going for transposing. Okay, so now we are going to see the formula for inductance and capacitance. Okay, this is the formula. You know very well. Inductance is 2 into 10 power of minus 7 ln of dm by ds. Okay, so if it is a single phase, this ds is r dash 0.7788 into r, and dm is spacing between the conductor d. Okay, so this is a single phase. Dm can be otherwise known as GMD, geometric mean distance. Okay, ds is otherwise known as geometric mean radius. Okay, GMR. So you can use both the term. Only thing is you have to you should able to classify where to substitute this r dash and where to substitute this d. Okay, now we are going to see a three-phase single circuit line. So we are going to use these two formulas. Okay, so here 2 into 10 power of minus 7 ln of dm by ds. So if it is a single circuit solid conductor, your ds is r dash and dm is cubic root of dab bcca, which is given here. Okay, similarly for double circuit, bundled conductor means your dm is replaced with ds1, s2, s3, and ds1, s2, s3 you can calculate using the formulas. Okay, you take down this formula which we are going to use in the circuit. This is the formula for capacitance. So 2 pi epsilon naught divided by ln of dm by ds. Okay, it is similar what we are going to what you have used in the T and D. You take down this thing. Now we are going to solve the problem. Shall we move for problem?
Yes, ma'am.
Is my screen visible for you, Kana?
Yes, ma'am.
Okay. So you see this video first for calculation. Let me give you time for doing your calculations. Then we go for your software. See, if you're having any doubt or if you're facing any difficulty, you stop me. I'll pause the video and I'll explain you.
One three phase. This is our case 1 3 phase single circuit solid conductor. So problem is determine the inductance per kilometer of a three-phase transmission line of 1 centimeter radius when the conductors are separated at the corners of a triangle, which spacing 2, 3, 4 centimeter are equally transposed. Okay, determine the conductance, inductance and capacitance. This is capacitance and inductance. Okay, so with the given data we can draw. It is the conductors are placed at the corners of a triangle. So A, B, C, the distance are given as 2, 3, 4. So AB is 2, BC is 3 and AC is 4. Okay, so we know that the formula for inductance is 2 into 10 power of minus 7 dm by ds. So we know how to calculate your dm, which is nothing but cubic root of AB, BC and CA. So multiply this thing, we will be having your dm, and ds is nothing but r dash 0.7788 into radius. So this is the value. So 2 into 10 power of minus 7 dm by ds. If I substitute, I will have the inductance value as 1.18 millihenry per kilometer. Then capacitance, same thing, 2 pi epsilon divided by ln of dm by ds, same thing. So here instead of ds we have to r dash, here we have to substitute our r. So r is the radius, so the value of capacitance is 9.815 nanofarad per kilometer. After calculating using the formula, you have to put a tabular column like this. See, first case 1, 3-phase single circuit solid conductor. So L and C are the parameters. So theoretically, I have calculated 1.18 millihenry and as inductance and 9.15 nanofarad as capacitance. Now
See, you try to solve this problem, Kana. I'll give you 5 minutes time. After that, we will discuss the answers. Then we will proceed. Am I audible? Is it okay? See, reply me in the chat box at least.
Yes, ma'am.
Thank you, Puvidi.
மேம் ப்ராப்ளம் ஒரு முறை காமிக்கிறீங்களா மேம்? சரி நோட் பண்ணாம.
Okay, Kana. Once you solved, no, Kanna, so that we will proceed to next. Have you all finished, Kanna? Will we proceed to? Are you sir?
Ma'am.
Yes, Kanna. Are you getting the
Ma'am.
answer? Just a second. Hmm. Answer? Yeah.
0.7788 into 1.18 millihenry per kilometer. Then capacity. So here instead of a kilometer, like this. See, first case one.
This I have got. What is the answer you are getting, Kanna? The same thing? Anyone? Am I out? You will get if Okay, so now we are moving to your case 2.
Three-phase single circuit solid conductor. So L and C are the parameters. So theoretically I have calculated 1.18 millihenry and as inductance and 9.15 nanofarad as capacitance. Now we are going to see how we are going to calculate practically. So this using your AU Power software.
See, have you got the answer, at least anyone? Reply me, Kanna. Am I audible?
Yes, ma'am.
Same answer you got.
Yes, ma'am. I have
Okay, good.
calculated in Henry meter, ma'am. But
No problem. Okay, now I'm going to show you how to do it in the software. You people listen carefully because you're not going to do in person. With this, you have to understand the experiment.
yes, ma'am.
Okay. Is my video is visible?
Yes, ma'am. Visible, ma'am.
Okay.
So this is AU power in which we are going to do this simulation. Okay, so if you double click this icon, so it will work. So this AU power is coded by a student who is an student of Anna University. So if you have to give your name and all. So I am giving a Saravanan. So you have to give your roll number, everything. If you go inside, so you will have these many options. We can solve using this software. For example, load flow, line constant, fault analysis, economic dispatch, transient stability, everything. So out of this, we are going to concentrate on only 1 and 2. One is your line constant, another one is your modeling of analysis. Okay, so first one is line constant. So in the evaluation of line constants, we have two options. One is LC evaluation, another one is your modeling of transmission line. Okay, so in that first option I am going to give. So it is your LC. So in this we have to go for a menu icon project. In that you will be having a new. So you have to go for data preparation. So if we have to go, we have to select which type of transmission line we are going. So first case, 3-phase single circuit I am giving here. So if I give 3-phase single circuit, this is the configuration, it is there. So we have to enter the data from the question. Okay, first data is distance between the conductors A and B in meter. Okay, so it is given as 2 meters in the question. Okay, so I am entering here as 2. Next, B and C, it is 3 meter, it is given in the question. And A and C, it is 4 meter. See, I think while writing, I have told it is centimeter in the question. It is not centimeter, distance is meter. You correct it in the question. Okay. So conductor diameter. So radius of the conductor is given as 1 centimeter in the question. So if radius is 1 centimeter, diameter we have to give 2. Okay. So geometric mean radius is r dash. R dash is nothing but 0.7788 into r. So radius is 1. So 0.7788 into 1, it is 0.7788 directly we can give. Number of bundle, see, since it is a solid conductor, I have to give 1. So no bundle spacing is there, I am giving as 0. These are the data. Just we have to enter the distances and the GMR and bundle spacing. Save. So it will ask some name. So I am giving as pre-LC. For my name I am giving. So save. So it will get saved. So after saving the data, you run it. So once you give, program completed successfully. So it has run. So now go to view menu, output. So if you go and see, you will have this thing. So this is the output. Okay. So if you see here, this final one, inductance is 1.18, and micro Henry per kilometer and millihenry per kilometer, and capacitance is 9.8 nanofarad per kilometer. So this is what we have calculated using our theoretical calculation. Okay, so 1.18, 9.8. So in the column of your practical, you have to write what you are getting in the output of the simulation, 1.18 and 9.8.
See, listen, Kanna. So after doing each case, you have to put a tabular column. So initially, theoretical calculation, and you have entered the values for theoretical, and then we did it in the software, and we have took the output. See, it should not be mandatory exact answer. 95% you will have a correlation. Okay, sometimes instead of 1.18 you will have 2 or 1.99, because in the calculation up to 1 digit, so it will make answer. Is it clear for you, everyone? Shall we proceed to the next one?
Yes, ma'am. We can
Oh,
go to next question, ma'am.
going for your case 2.
So next one is your case 2. Case 2 is 3-phase single circuit bundled conductor. Okay. So we are going to use the same question what we discussed for solid conductor. Same question with same diagram. Only one thing is, instead of this solid conductor, I am going to use bundled conductor. So I can redraw the diagram as like this. So A phase is having two conductor bundle, B phase and C phase. Remaining distance are kept as previous. Okay, 2, 3, 4. Only thing is, two bundled conductor and the bundled spacing is taken as 45 centimeter. Bundle spacing as 45 centimeter. So
And you calculate value for your case 2, 3-phase single circuit bundled conductor with bundle spacing 2. Okay, I'll give you 2 minutes. You take down the question, then I'll show you the formulas for you. You see that formula and you have you copied?
Huh?
Yes.
Bundle spacing value is 45 centimeter.
Yes, Kanna, it is 45 centimeter.
Yes. Thank you, ma'am.
See, is the formula is visible, Kanna, in the PPT?
PPT is
ma'am.
not visible.
Okay, okay. Now is it visible?
Yes, ma'am. Now visible, ma'am.
Okay. So your is here in the second bottom of your DMS cube CCA. It is similar to first one, and DS you have to calculate with this formula A dash and A dash A dash. So if you see here, instead of your A and A dash, you have to go for your R dash, and remaining thing you have to substitute your D. Okay, so R dash is 0.7788 in, and your D is, it is given there. You substitute here, and you find the values of ds and dm. Substitute in inductance formula, you will get the values. Have you calculated, Kanna? So you use this formula, or else if you are very bundle ds square root of r dash, நீ அப்படி பண்ண, this is the formula. பண்ணா நான் d square r d square. So if you simplify this thing, ds will be root of r dash d square, sorry, r dash d, if it is a two bundle conductor. See, let me show that also.
Ma'am,
Is this
diameter
picture
of the...
visible, Kanna? Is this picture visible, Kanna?
Yes, ma'am.
See, this is the shortcut you have solved, right? In your TND. So, if two bundle is there, you substitute GMR is for dash D. Bundle, cubic root of r dash D square. If it is a four bundle, fourth root of r dash. substitute. As can directly substitute instead of this formula also. Yeah, tell me, Kana, someone have asked me something.
Yes, ma'am. Ma'am, diameter of the conductor is now given.
See, it is like a previous problem. I think it is one.
One
A
centimeter.
problem la da modify.
Yes, ma'am.
See, radius is given as 1 centimeter. So in that case, your need for diameter நம்ம எங்கேயும் யூஸ் பண்ண மாட்டோம். See, this D is bundled spacing, not diameter. அதுல கன்ஃபியூஸ் ஆயிட்டீங்களா?
நோ மேம், ரேடியஸ் வந்து கொடுக்க இது முன்னாடி சம்ல இருந்து காப்பி பண்ணணும்ல, இதுக்கு வேறையோ நினைச்சிட்டு கேட்டுட்டேன்.
ஓகேடா, ஓகே, no problem. The same radius. Only thing is solid conductor is replaced by bundled conductor with bundle spacing 45 centimeter.
Thank you, ma'am. Yes, ma'am.
Okay, Kana, let me play the video and complete it for this one. So for time being, you note down the answers and you solve it in your notebook. If you are facing any difficulty, you can. Okay. Video visible? Anyone reply me?
Yes, ma'am.
Okay, thank you.
மேம் வீடியோ வாய்ஸ் கேட்கல மேம்.
Video voice கேக்கலையா? Wait, let me wait.
Only thing is two bundled conductor and the bundled spacing is taken as 45 centimeter.
Now it is okay, Kana?
Yes ma'am, now okay ma'am.
Okay, thank you, Ravi.
0.91. So it is equal to your ds 5.91. So we know the formula for inductance 2 into 10 power of ln of dm by ds. So dm by ds substituted, the inductance value is 0.77 microhenry per kilometer, so millihenry per kilometer. Similarly, epsilon naught, so you will be having 14.77 nanofarad per kilometer. So after calculating, as usual, you have to enter the tabular column here. Case 2, 3-phase single circuit bundled conductor LNC. So practical value sorry, theoretical value is 0.77 and 14.7.
See, you note down this value, Kanna, so that you can.
7. As like our previous case, we have to go for project, new, data preparation, 3-phase single circuit again. So here, see, you have to type the title of the exercise. Here you can type it as double circuit bundled. Single circuit bundled. Okay, as usual here the distance are not changed. In our previous the same we are so the distance between your A and B conductor is 2 and the distance between B and C is not changed, again 3, and A and C is 4 meter. Conductor diameter also not changed, it is 2, or here it is this is the value of same R dash 0.7788. So here you are writing 0.7788 and a number of bundled conductors here in case 2 you are using 2 conductor per bundle. Bundle spacing it is given as 45 centimeter in the question itself. So same, only thing which is going to be changed for case 2 is your bundle conductors and your bundle spacing. Save it. So as usual, going to give any name as. So after saving it, run it. So successfully run. So view output. So you can see the output here. So inductance per phase is 0.77 millihenry per kilometer and capacitance is 14.7 nanofarad per kilometer. So this is what we got in the tabular column also. So 0.77 and 14.77.
So this completes your case 1, Kanna 1 and 2, which is 3-phase single circuit and solid and bundle. Okay. Now going for your 3-phase double circuit solid and bundled. Okay. Am I clear? Shall I proceed?
Yes, ma'am.
Okay. So first I'll show you the problem. You copy it, then I will play the video. You copy the problem. This is the problem, Kanna. I think it is visible in the video. Have you copied, Kanna? Shall I play the video?
Ma'am, readings are not visible, ma'am.
I didn't get you.
Ma'am,
See,
readings வந்து visible
not
இல்ல
visible.
ma'am.
Let me read out it.
Ma'am, yes ma'am.
As a part of transposition of your transmission line, 3-phase circuit is shown here. So left side ABC, A dash, B dash, C dash. Is it clear? Adu clear arka? Now I'll tell you the distance distance between A and C dash is 5 meter. A and C dash is 5
Yes,
meter
ma'am.
and B and B dash is 6 meter. Okay. And
Yes,
C
ma'am.
and C dash is again 5 meter. Okay. And
Okay, ma'am.
AB horizontal distance, not கிடையாது. Distance between your is 4 meter. Is it?
Yes, ma'am.
And vertical distance between your middle and bottom conductor is again 4 meter. Okay.
Yes,
Apart
ma'am.
from this, the
Yes, ma'am.
radius of 0.9 centimeter. The conductors are solid conductor. Solid. Is it clear, Kanna?
Yes, ma'am.
Okay. You note down it. I'll play the video. You make a note of it, all the answers, and then I'll give you time for solving. Okay.
Okay, ma'am.
Thank you.
Okay, ma'am.
Okay, Kanna, like this, if you're facing any difficulty, you stop me then and there, then it will be easy for everyone.
So next one is our case 3. So case 3 is nothing but 3-phase double circuit solid conductor. So 3-phase double circuit, we are going for your hexagon configuration A, B, C, A dash, B dash, C dash, since it is a transposed line. So as a part of transposition, the three of cycle, 3-phase circuit is shown in the figure. Radius of the conductor is taken as 0.9 centimeter. Conductors are solid conductors, that is copper conductor. Find the inductance, capacitance per phase per kilometer of the line. So the distance are given here. So horizontal distance between the conductors is 5 meter and the B and B dash is 6 meter. C and A dash is again 5 meter. And this vertical distance is given as 4 meter and here it is 4 meter. It is the data given in the question. So with this, we know how to calculate our DM and DS. DM is Q is 4 DAB, BC and CA, cubic root of DS is cubic root of DSA, DSB, DSC. So here DAB can be calculated by 4th root of DAB, DA dash B, DAB dash, DA dash B dash. So similarly BC we can calculate 4th root of DBC, DB dash C. Yes. Sim is equal to 4th root of CA, C dash A, CA dash, C dash A dash. So substitute this thing by calculating using your mathematical calculations. We can able to find the values of DS and DM and DS. Okay. So if you substitute all these things, your DM will be 5.57. Okay. And DS is cubic root of DSC, SBSC. So S is equal to 6.7. If you substitute inductance formula, you are getting inductance as 0.63 millihenry per kilometer. And if you substitute, you will have capacitance as 18.77 nanofarad per kilometer. Next one is case 3. Case 4.
See, listen, Kanna. I didn't show you the formula for DS there. Yeah. Now let me show you. Is the PPT visible? Is the PPT visible, Kanna?
Yes, ma'am. Yes, ma'am.
Okay, okay. See, here I have shown you the formula to calculate your DS. Okay, DS is cubic root of SA, SB, SC. So SA you will calculate like this: AA, AB, A dash B, and A dash A dash. Similarly, BB, BB dash, B dash B, and B dash B dash. CC, C C dash, C dash C, and C dash C dash. You take down this thing and you substitute. இப்போ DAA க்கு பதிலா என்ன substitute பண்ணுவோம் கண்ணா? DAA க்கு பதிலா என்ன substitute பண்ணுவோம்?
R dash.
R dash. Okay, very good. And A dash you will substitute from your here. How will you substitute your A dash A dash? A dash க்கு என்ன பண்ணுவோம்? See, listen. This is a solid conductor இல்லையா? In that case, DS க்கு பதிலா directly you can substitute your R dash. That itself enough. Okay va? Or else you calculate the distance between your A dash from the figure. Okay, and the hexagon spacing la A dash கண்டுபிடிக்கணும். A dash A and A dash A. Instead of your AA and A dash R dash substitute பண்ணுங்க. Is it clear? Shall I proceed? Anyone?
Yes, ma'am.
Okay. So இங்க AA க்கும் A dash க்கும் பதிலா you have to substitute R dash. A dash and A dash A you have to calculate from the hexagon configuration. Similarly, B dash substitute R dash. CC and C dash substitute R dash. B dash and B dash B, C dash and C dash C you calculate from the hexagon spacing. Is it clear? Now, bundled conductors க்கு இந்த formula என்ன மாறும் கண்ணா? இப்ப நம்ம அடுத்தது 2 bundle பார்க்க போறோம் இல்லையா? What the thing you have to change in this formula? DM மாறுமா? Hello? Am I audible? Am I audible Kanna?
Yes, ma'am. Audible.
Okay. DM we should not change. அது மாறாது. For DM, even if it is bundled conductor, we have to solve like considering as a solid conductor. So இதுல changes இருக்காது. DS ல you have to change it at only one point. இந்த DAA க்கு பதிலா A dash க்கு பதிலா என்ன substitute பண்ணுவோம்? Square root of R dash D substitute பண்ணணும் because it is a 2 bundled conductor. மத்தபடிக்கு ரெண்டு கேஸ்க்குமே same formula you have to substitute. For first case R dash substitute பண்ணுவோம். Second case DS ல DAA க்கு பதிலா square root of R dash D substitute பண்ணுவோம். அவ்வளவுதான். Is it clear? Is it clear Kanna?
Yes, ma'am.
Okay. Is the video visible Kanna?
No, ma'am.
Okay. You tell me Kanna, since I am stopping and presenting, I got confused. Now I should present my video.
Case 3. Sorry, case.
Now it is visible.
Yes, ma'am.
4 3-phase double circuit bundle. As previous problem, we are going to take this same configuration. Only thing going to vary is your 2 bundled conductor for each phase. Okay, so in case DM 5.5 will be changed as 0. So if you you will have 0.427 millihenry per kilometer, and if you substitute in capacitance 26.7 nanofarad. So this is for case 4 3-phase double circuit bundled conductor. So after calculating using the formulas, you have to put this tabular column for case 3. So parameter is LNC. I have put the theoretical values. Similarly for case 4, 6, you have to fill the theoretical column, software, the practical column. So project, new, data preparation. Here you have to select an option, 3-phase double circuit vertical configuration. So it will go here. So if you see this diagram arrangement itself shows that it is an hexagon configuration. So S11, if you see the figure, S11 is distance between the topmost two conductor horizontal distance. So in the figure it is given as 5 in the question, and meter, topmost is again 5 meter. Vertical distance between conductor is, and distance between middle and bottom conductor is again 4. So conductor diameter, so radius they have given as 0.9, so conductor is diameter is 1.8. So GMR, here you have to substitute the GMR R dash, which is 0.7788 into 0.9, which is nothing but 0.7. So number of conductors, it is a solid, spacing is 0. Name, successfully run, view output. So you have got the output as 63.63 millihenry per kilometer and 18.36 nanofarad per kilometer. So if you see for case 3, in the theoretical also we got 0.63, in practical also 0.63 millihenry. Similarly for capacitance 18 nanofarad, here also 18 nanofarad. So now we are going for case 4, again project, new, data presentation. So 3 double circuit, bundled. So here also the distance will not going to change because we are using the same data. Only difference is instead of solid conductor we are going to use here bundled conductors. Okay, so 5, 6, 5, 4 vertical between top and bottom, middle and bottom. Conductor diameter is 1.8 and geometric mean radius. Here you have to substitute the values of your ds. What you have calculated using the calculation, it is 0.66. Okay, so number of bundle conductor is 2, 45. Another name, run, view output. So you will be having the output. So these are the data we are giving, and inductance as 0.42 and capacitance as 27.1. This is our key.
So like this, you have to calculate the value of inductance and capacitance. Okay. Am I audible, Kana?
Yes, ma'am.
Okay. So you have a note of all these things. We will send you the link for this YouTube. Okay. So we have posted this in the YouTube itself. உங்க groupல நாங்க link அனுப்பிச்சிடுறோம். So whenever you want to watch this, you watch this. Be prepared because next you are going to have your model exam. Model exam அப்ப you have to explain all those things. Okay. Is it clear? It is an open link. It will be sent into your Google, WhatsApp group. You kindly go through it. Any doubt for anyone, Kana? If not, I will move to the next one. Am I audible? Radhi?
Yes, ma'am. No doubt, ma'am. We can proceed
Okay,
now.
okay. So you write the problem, do the calculation, put the tabular column. So like this, you have to do it for 4Ks. You have to scan those solved copy and you have to upload in the Google Classroom. Okay. So that is why I'm insisting again and again. You note down the formula and you note down the problem. Be ready with it. Okay. So next thing, what we are going to show is your next experiment, modeling of transmission line. Is my presentation is visible?
Yes, ma'am.
Okay. So experiment 2 is your modeling of transmission line. So here you are going to analyze the performance of your transmission line. Okay. So we know that the lines are classified into short, medium and long. Only thing we are going to concentrate here on medium line and we are going to discuss the parameters. Okay. So if I want to analyze a transmission line, first thing I have to analyze is your voltage regulation and efficiency. So in order to calculate your regulation and efficiency, we have to calculate all those ABCD parameters. Okay. You see, this is the general expression or matrix equation, which is for calculating your sending end voltage and sending end current. Vs is equal to A into VR plus B into IR. Is is equal to C into VR plus D into IR. This is the generalized expression. And we know that the values for ABCD varies for different lines. Okay. Since it is an uh, medium transmission line we are going to use in this experiment, I'm going to concentrate on that one. So medium line pi method. Okay. This is the equivalent circuit of your medium line pi method. So your impedance is entirely distributed. The admittance is divided into twos on either side of your transmission system. V by 2 in the sending end side and another half in the receiving end side. And the values of your ABCD constants are A is equal to 1 plus Zy by 2, B is equal to Z, C is equal to Y into 1 plus Zy by 4, D is equal to 1 plus Zy by 2. Okay. You have to calculate this thing and you have to substitute here and you have to find the values of VSIS. From VSIS, we know the formula for regulation, Vs divided by VR into 100. Okay. So then efficiency, output power divided by input power. So you substitute there and you have to find the values. Okay. You take down this equivalent circuit and this constant value. I'll give you 2 minutes time. Have you copied, Kanna? Shall I go?
Yes, ma'am.
Okay. Now I'll play the video. Is my screen visible, Kanna?
Yes, ma'am.
Okay, thank you.
Experiment 2, modeling of transmission line. So here we are going to model and analyze the performance of short line, medium line and long line. Okay, so in the medium line it is further classified into T method and pi method. Okay, so your pi method is normally used method for practical analysis of transmission line. Okay, so in our problem we are going to consider a medium transmission line for analysis. So this is the problem we are going to consider. Let me read out the problem first. A three-phase transmission line of 100 kilometer long has the following constant. So resistance per phase per kilometer is 0.2 ohm. Inductive reactance is 0.63 ohm. Capacitive susceptance per phase per kilometer is 4 into 10 power of minus 6 Siemens. If the load at the receiving end is 75 megawatts, at power factor 0.8 lagging with an voltage of 132 kV within the lines. Calculate the sending end and receiving end voltage, current, power factor, voltage regulation and efficiency using nominal pi method. Okay, so for this experiment, we have to calculate sending end voltage, sending end current, sending end power factor, percentage of voltage regulation and percentage of efficiency. Okay, so the data given are the receiving end voltage and receiving end power.
See, you note down the question, Kanna. Okay, then only it will be easy for you. Note down the question. So once you copied, anyone acknowledge me, I'll play the video.
PR is given in the question. Okay, so we know that
Have you copied, Kanna?
Yes, ma'am.
Okay, let me play the video. See, you continuously watch the video. It will have both the simulation also. After that, you'll try to solve the problem.
And efficiency using nominal pi method. Okay, so for this experiment, we have to calculate sending end voltage, sending end current, sending end power factor, percentage of voltage regulation, and percentage of efficiency. Okay, so the data given are the receiving end voltage and receiving end power PR is given in the question. Okay, so we know that this is the generalized constant matrix constant for transmission lines. Okay, sending end voltage parameter is equal to line constant into receiving end voltage parameter. So Vs is equal to A into Vr plus B into IR. Similarly, Is is equal to C into Vr plus D into IR. So this we already know. So now we have to calculate the values of your A, B, C, D, because Vr and IR it is given in the question itself. So Vr it is given as 132 kV. From real receiving end power, I can able to calculate my receiving end current. Okay, so the constant formula for your medium transmission line are for A 1 plus zy by 2, for B is equal to z, C is equal to y into 1 plus zy by 4, and A is equal to D, which is again 1 plus z by 2, y by 2. So for calculating your constant A, B, C, D, we have to calculate the values of impedance and your admittance. So what is the formula for impedance? Z equal to R plus JX. Similarly, admittance Y is equal to G plus JB. Okay, so now with the given data R and X, we have to calculate your Z. So if you see the question, resistance per phase per kilometer is 0.28. So the length of the line is 100 kilometer. So if I want to calculate resistance for the entire line, so 0.28 into 100 I have to put. Similarly for inductive reactance, it is given as 0.63 ohm. So I have to multiply with my length of the line. So it is given here. So Z per kilometer is 0.28 plus J is 0.63. So if I want for the entire length, I have to multiply with my 100. So Z is 28 plus J 63 ohm. Okay, next we are moving for admittance. So admittance is G plus JB. So conductance we are assuming as 0 since it is not given. And B is susceptance. It is given in the question. Capacitive resistance per phase as 4 into 10 power of minus 3. So here I have to write it as JB. So that is why I am writing here as my JB. So Y is equal to J 4 into 10 power of minus 6 mho. Okay, so now I am going to substitute this Z and Y, and I am going to calculate my A value and B value and C value and D value. So after calculating the A, B, C, D, I am going to calculate my VSVR using this matrix VSIS ABCD into VRIR. So VR, it is given in the question as VR 132, it is a line voltage. We have to convert this to phase voltage. So 132 divided by root 3, which is 76.21 kV. So next, the given data is PR, it is suffix R. So root 3 VRIR cos phi R. So cos phi R is given in the question as 0.8. So VR is, we have calculated here root 3. So if you substitute here, IR is equal to PR divided by root 3 VRIR cos phi. So you can get the values of IR. So after calculating your VR and IR, if I substitute here A into VR plus B into IR, we know the values of A and VR. Here you have to substitute your phase value, not 132, and similarly B into IR. So you will be having your VS value. So after calculating your VS, similarly C into VR plus D into IR gives my IS value. So I have calculated my VS and IS. After that, I am going to calculate my percentage of voltage regulation. VS by A divided by VR into 100. So if you substitute this thing, you will be having the voltage regulation as 27.15 percentage. Then the next thing I have to calculate is my percentage of efficiency. So output power divided by input power. So VR IR cos phi R divided by VS IS cos phi S. So I am having the efficiency as 87.8 percentage. Then we have to calculate our phi S also. So phi S we are calculating from the VS value. Angle of your VS gives your phi S. So cos phi S is 0.7788. Power factor at the sending end voltage cos phi S. After calculating all the parameters, you have to put a tabular column. So medium transmission line, pi method. So what are all the parameters you have calculated? A, B, C, D, Vs, cos phi S, VR and voltage regulation and efficiency. So these are the values I have calculated, I have put here. Practical value after doing from the experiment, you have to write here and you have to compare what is the value you are getting.
See, now you calculate the values using the formula, Kanna. I'll give you 5 to 10 minutes time. Then we will have how to do it in the software. Okay. Am I audible?
Yes, ma'am, we can do now.
Okay, thank you, Soumya, Radhi. Have you solved, Kanna? Are you getting the same answers? Okay, you note down this answer. Let me continue for software. You solve it again and you cross check with answers. Okay, you note down in your notebook. This is the theoretical answers for your ABCD, VS, cos phi s, VR, and efficiency. Is it okay? Am I audible, Radhi?
Yes.
Yes, ma'am.
Okay, okay, okay.
So modeling also we are going.
Is video is visible?
Yes, ma'am.
Okay, so after seeing this, we will post you the link, Anna. You go through it and you should be ready with all your calculations and tabular column. Okay, we will give you instruction what to do further.
Going to use the same AU power. So it is similar to your line constant. We have to choose the line constant option, and in that line modeling and analysis. So in that, as usual, you have to create a new project data presentation. So here medium line you can give. So medium line analysis. So resistance in ohm per kilometer, it is given in the question as 0.28. So I am entering as 0.28. Similarly, series inductance, it is given in the question as inductive reactance. It is given in the question as 0.63. So from Excel, we have to calculate the values of our L. So we know the formula XL is equal to 2 pi FL. So L is equal to XL divided by 2 pi F. If you substitute XL 2 pi F, you will be having the values of L as 2.005. Similarly, we have to calculate the values of capacitance also. So for capacitance, in the question, B is given. Okay. B is your susceptance value. Relation between your B and capacitive reactance is B is equal to 1 divided by XC. So we know that XC is equal to 1 by 2 pi FC. So if I substitute XC here, this denominator term will go to the numerator term. So B is equal to 2 pi FC. So C is equal to B divided by 2 pi F. So B is given in the question. So I am substituting here. I am having the capacitance value as 0.0127 microfarad per kilometer. So now I am going to substitute these two things. So inductance value as 2.005 and capacitance value as 0.0127. And conductance we are assuming as 0, frequency is 50, and length of the line it is given as 100. I am going to save here. And here if you see, based on the given data, we may have 3 different types. If you see, take first type, we know this receiving end quantity, we have to calculate our sending end quantity. If you see the second type, to calculate receiving end with specified sending end. Okay, so other things are to calculate sending end when load impedance is specified. So if you see our question, it falls on your case 1 to calculate the sending end quantities for the specified receiving end power and real and reactive power. So click this one. A window will open. Here you have to enter the receiving end line voltage. It is given in the question as 132 kV. Then you have to give the angle of receiving end voltage. Obviously we are taking receiving end voltage as reference value. So angle of your reference voltage is 0. Then you have to calculate your real power P and reactive power Q. So we know that P is equal to VI cos phi. Okay, so this VI is the apparent power we can write. So S into cos phi gives you real power. So in our question, our apparent power is given as 75 MVA. So if you have 75 into 0.8, you will have the values of your 60 real power. Similarly, Q is equal to S into sin phi. So S is 75. So if cos phi is 0.8, sin phi will be obviously 0.6. Okay. So you calculate using your calculator cos inverse of, put your cos inverse and then take your sin. So if you put this thing, you will be having 45 megawatt. This is watts and this is var. So substitute here as your 40 as your real power, sorry 60 as your real power and 45 as your reactive power. Save here and I am giving a name. Save it. Now run. It is successfully run and view output. So if you see, these are all the data we have entered and finally we have got our for voltage regulation and efficiency. Regulation is 27 and efficiency is 87, what we got in the theoretical calculation also.
Hi friends, welcome to
Is it okay, Kanna? Any doubt for anyone?
Clear, ma'am.
Okay, this completes your experiment 1 and 2. If you're having any doubt, you ask me or you post it in the WhatsApp group. Okay, we will clarify you. The link will be posted in your class group. Okay, so with this we are wind upping for today's class. Niveda, are you there, Kana? 63.
Yes, ma'am.
You transfer the ownership, Kana. The video is recorded in your link. Okay.
Okay, ma'am.
Kindly